Hello everyone, my name is Manvita Reddy Chintalapalli and today I am going to present my data mining project which is water quality prediction using KNN and classification tree. So the problem addressed in this project is to determine whether given water sample is safe or unsafe by analyzing water quality data. The main aim of the project is to predict uh, models by using classification algorithms like KNN and the classification tree to check the water safety so that this can save time and people by spotting the unsafe water early for consumption. So moving on to the data set. So this is an overview of the data set, and I obtained this data set from the Kaggle website. And this data set consists of the chemical substances from the water sample, uh, which helps us to predict whether the water is safe or unsafe. And this is the simple data set. We have values like measurements like the chemical levels of the chemical substances like the aluminium, ammonia, cadmium, and etc. So since these values are kind of like the measurement values, so this can be considered as a continuous numericals, and we have one output variable which is safe. Uh, it contains values like 1 and 0. 1 is nothing but the water is safe, and the 0 is nothing but water is unsafe. And since for example like the text variables or the 1 and 0 numericals can be considered as a categorical variable. So since our output is a categorical variable, we'll perform classification task on this data set. Moving on to the next slide. So data set cleaning process. So we usually do the missing data handling so that if we find any redundant data or if any blank cells like irrelevant data, so that can be treated in this process. We did the missing data handling on this data set since all our variables are like continuous numericals, so those can be selected as mean. And one column can be ignored, which is serial number. So it's a meaningless and it's not relevant to the task. It's that can be ignored while predicting. So we have not included that particular column, and the rest of the columns are included in the missing data handling. And after performing the missing data handling, we have like three records treated from the column ammonia, which is good. At least we have found three records. And since the output variable is categorical variable, will perform the classification, and all other variables are like the continuous numericals. So they are not like the text variable, so no need to create the dummy creation. And since output is categorical, so no need to perform the scatter plot matrix as well. Moving on to the next slide. So PCA technique. PCA is nothing but principal component analysis. So I have used PCA technique to reduce like the dimensions, to reduce the columns which are not important for the prediction. So we only select the variables which are important for predicting. I mean, to predict the accurate results. So we can reduce some of the columns and only select the important ones. So here, after doing the PCA technique, I have like the five components, top five components I've selected, which is bacteria, chloramine, cadmium, lead, and the selenium. So why we do PCA is nothing but so that it can reduce the dimensions and provide the accurate results. Since we have only have the continuous numerical variables, so that by using the PCA these can turn into like the smaller set of components called the principal components, which helps us to provide the accurate predicting results. Moving on to the next slide. So why KNN and the classification tree? So KNN is nothing but the K nearest neighbors. So it is one of the supervised machine learning algorithm which is used for the classification and the regression task. So KNN is like simple and effective algorithm in the machine learning. It works with finding the K nearest neighbor to a new like input or the data point, and then makes a prediction according to those neighbors. So, for example, if we take the classification task, KNN assigns the most frequent class label among the K nearest neighbors to the new data point. For example, if we take one row of a data set and compare with the nearest neighbors, like if you find any similar type of values, like if two rows have like similar kind of like data, like almost matches with the data point, then those are called the K nearest neighbors. So KNN is like also known as a lazy learner because it doesn't like learn a model; it memorizes the training data. So here the KNN is like the performance depends upon the KNN value. It's like although KNN is like works well with smaller data set, it's not like that effective for the larger data set because it's not easy to find the distance if we have like so many training data points. It's not easy to find the distance bit from the new data point to the training all the training data points which we have in the data set. So it's not effective for the larger data set. So other KNN is like quite powerful because it's used in the pattern recognition and image classification as well. It's like easy to understand and implement, and also like highly effective for classification and the regression task. So the classification is also a supervised machine learning algorithm which works for both the classification and the regression task. It is also like the decision tree algorithm, which the data is classified into categories to predict whether the water is safe or unsafe. This follows like the divide and the conquer method, which is like it has the uh, algorithm usually works by splitting the data into two parts. Like it goes like the tree method, like the root node, and it branches out into two parts and check whether the water is safe or unsafe at each level. And the classification tree algorithm is like easy to visualize and interpret the data, and also works well with both numerical and the categorical variables, like all the continuous and the categorical variables. It works with both, and one major advantage we have with the classification is like they require high data minimalizing, such as like the normalization technique. And due to this, like due to the over data, which if the tree is like complex and goes into deep, the one problem arises is like overfitting, and to overcome that they can be used like they can be like prune and also use the maximum tree depth technique. And this one is also like highly effective, and we got more accurate results with the classification tree rather than the KNN tree. Although KNN is also like works well with both the continuous numericals, I mean it works well with the similar kind of data. So since we have used these two algorithms to predict the water levels in this project. Moving on to the next slide, we have model table for KNN algorithm. So we have created like six models, and one model is with the PCA, which we used only the top five variables for the partition, and the rest of this five models is with the regular partition. Like we have used all the variables, all the continuous variables for the partition, and we have performed algorithm on all the variables. And with one model only we have used with the PCA, and only we have used those five variables. So here I've chosen like different KNN value. For the PC I've used the maximum KNN value, which is 10, and almost I got the accuracy of 88.87, which is good. Anything over like around 70% of accuracy, anything above 70 is like high for the data mine. So here with the PCA we have got 88.87, and the rest of the models we got around like about 80 only. And the highest, the best model we got is for the regular, which is KNN value of 10, 90% training, and the 10% validation, which is around 90% of validation accuracy, which is very good, very effective results for the KNN. And if you go to the next slide for the classification tree, And here also the same, we have created six models. One is with the PCA and the rest are with the regular. And here the best model we got with an accuracy of 96%, which is also a regular, which is 90% training and the 10% validation, which is very effective. If it's above 90, it's very good. We got good accuracy results with the classification tree compared to the KNN, and the classification is also like took less time for the data processing. So, and KNN took kind of like more time, and the classification provided more accuracy and in less time, like the faster results. So moving on to the next slide, which is scoring results. So what we have done is once we perform the algorithm, we choose the best model to deploy for the scoring results. So for both the best, we got the best models with the 90 and the 96% accuracy for both the algorithms. So we have chosen those two algorithms to deploy and like those two models to deploy, and we got the very good scoring results for the KNN and the classification tree. So these are our scoring results for both the algorithms. And moving to the next slide, conclusion. So we have successfully implemented both the classification and the KNN algorithms to predict the water quality, which is like safe or unsafe for consumption. And we have achieved like 90% of accuracy with the KNN and 96% with the classification tree. So overall, if we see like classification tree resulted like it provided more validation accuracy compared to the KNN, and it also provided like the faster results compared to KNN. So classification tree provided better results for us to predict whether the water is safe or unsafe to consumption. And moving on to the case studies for KNN, so we have found out two case studies, which is Amazon product recommendation engine, and the next one is the Spotify music recommendation system. So Amazon uses the KNN algorithm, to analyze the browsing history of the user and the purchase history of like what they have ordered or what they are checking or what they are interested in, so that it checks the user behavior, like what are they ordering, what are they using, so that it can compare with the similar interest of the people, similar interest of the user. Based on that, it recommend product to the users. So based on their purchase history, based on their interest, it can recommend products to the user. So by this, Amazon can get the customer satisfaction, good reviews in the recommendations, and also increase their sales as well. So basically, this is for user experience and the customer satisfaction. They can improve that. And the next one is Spotify music recommendation system. This one is also used. Spotify uses KNN, to track what people are listening, what people are interested in, like what kind of music they are listening to, their listening habits, or so that they can compare with the other listeners who have like the similar interest. Based on that, they can recommend songs, or else they can suggest some playlists as well, creates personalized playlist for them. For example, if they keep on listening to one kind of like singer they like, so that they can suggest that playlist according to the singer, like that. So by this, they can increase their user engagement, and also people can have like enjoyable music experience as well. Moving on to the next slide, case studies for the classification trees. Here we have two case studies, malignant melanoma identification. So in this particular case study, like a tree-based classification method was used to analyze like the dermoscopic images to identify this particular disease, so that this process can be like effectively handle complex data by using the classification tree. It also helps to identify and the differentiate benign and the malignant skin lesions. So as a result, what we can get is like it can improve diagnostic accuracy in skin cancer identification, based on those symptoms, which we can predict whether that particular person has this risk of cancer or not. And the other one is credit risk assessment in finance. It is nothing but classification algorithms were applied to banking to access the credit worthiness of the people who are apply for the loan. Like there, once they apply to the land, like factors need to be checked, like the credit history, or else how much they earn, like the income. So those all factors were included to analyze and predict whether this particular uh, person can get loan or not. By this, what we can do is like we can enable the risk. If a person is asking for high loan, like high amount of loan, so that we can check their credit income or like the credit history, and based upon that we can give the loan. So by checking those factors, we'll be like in less risk of losing like huge amount of money. So yeah, these are the two case studies I've found for the classification tree. So I'm done with the project presentation. Thank you all.